the Department of Education brings you Tele Class. Get your notebooks and pens and get ready for an exciting lesson today.
Hi, good day everyone. I am Teacher John and I welcome you all in our Mathematics 8 class. Before we begin, let's pause for a moment for a prayer.
Father in heaven, I stand before you today in your omnipotent presence to ask that you grant me strength. I want you to give me the strength to power through all of the tasks today, whether little or big. It is by your will that I live, O Lord, and I know it is also by your will I will not go weak today. I will not go lazy, nor I will fail to do all things set before me, because you strengthen me. Thank you for your everlasting presence, Lord, and in Jesus' name I pray. Amen.
Today is indeed a wonderful day for us to learn and understand mathematics. Are you now ready? Amazing! From the previous episode, we learned how to find the factors of sum and difference of two squares and factoring common monomial factor. Can you still recall the steps in finding those factors? Very good. So let us try this example.
Let us check your understanding about common monomial factors. All we have to do is tell whether the statement is true or false. You may write your answers on a piece of paper or you can use your notebook in mathematics. V plus 9 is one of the factors of v squared minus 49. The common monomial factor of 3x squared plus 2x is x. N squared minus 8 is a difference of two squares. X squared plus 2x is equal to x times the quantity of x plus 2. E squared plus 1 is prime. No other factors except itself and 1. The GCF of 12m cubed and 36m squared is 12m squared. GCF means greater common factor. W squared minus 100 is equal to the quantity of W plus 10 times the quantity of W minus 10. The quantity of A plus B times the quantity of A minus B is an example of sum and difference of two terms. C squared minus 6 is equal to the quantity of C plus 3 times the quantity of C minus 3. The answer for number 1 is false. Number 2, true. Number 3, false. Number 4, true. Number 5, true. Number 6, true. Number 7, false. Number 8, true. Number 9, true. Number 10, false.
There are cases that we factor polynomials in different ways. Like for example, the sum and difference of two cubes. And there are trinomials with varying signs to consider. So from finding the factors of difference of two squares, let's learn how to find the factors of sum and difference of two cubes.
Factoring sum of two cubes and difference of two cubes. Let's take a look at the following. For sum of two cubes, we have a cube plus b cube is equal to the quantity of a plus b times the quantity of a squared minus ab plus b squared. For the difference of two cubes, we have a cube minus b cube is equal to the quantity of a minus b times the quantity of a squared plus ab plus b squared. Remember, we will follow the SOAP technique to make it easier for us to understand. So S stands for same sign for the first factor, O stands for opposite sign for the second factor, first and second terms, and always positive for the last term. So for the sum of two cubes, as we can see, the first factor carries the same sign. For the second factor, we have an opposite sign and always positive sign. Same goes with the difference of two cubes. In factoring sum or difference of two cubes, we have the following conditions. First, it is a binomial. The constant must be a perfect cube number. For the variable, exponent must be a multiple of 3. Second, each term is a cube. Let's try this example. Example number 1, n cubed minus 8. Let's check if it meets the conditions. So first, it is a binomial. Check. N has an exponent of 3 and 8 is a perfect cube. Check. So remember SOAP. S stands for same sign, O stands for opposite sign, and AP stands for always positive. Alright, so first we have n, which is the cube root of n cubed. Next, 2, which is the cube root of 8. N squared, the square of n. Next, 2n, which is the product of n and 2. And lastly, 4, which is the square of 2. Let's move on to the next example. X raised to the 6th power times y raised to the 4th power plus 27. Let's check if it meets the conditions. First, it is a binomial. Check. Next, if you take a look at the exponent of y, it is not a multiple of 3. So therefore, it is not considered to be a sum of two cubes. So therefore, this expression is a prime polynomial, which means the only factors are itself and 1. For the third example, we have 1 plus e cubed. So let's check the following conditions. First condition is it is a binomial. Check. Next, 1 is a perfect cube. Yes, because if we multiply 1 times 1 times 1, the answer is 1. And e has an exponent of 3. So therefore, it is a sum of two cubes. So for the factors, remember SOAP. S stands for same sign, O stands for opposite sign, and AP stands for always positive. For the factors, first, 1, which is the cube root of 1. E, which is the cube root of e cubed. Next, 1, which is the square of 1. E, which is the product of 1 and e. And e squared, which is the square of e. So the factors of 1 plus e cubed is the quantity of 1 plus e times the quantity of 1 minus e plus e squared.
Can you understand the process?
Compared from the activity, we notice that they are not on the same order. However, the correct answers are still placed on the correct empty boxes. If you answered correctly, the order won't affect the answers.
Today, we are going to study the application of sum and difference of two cubes. You can look around and find these things that represents the cubes. For example, these dice, a bigger and smaller dice. If we put or combine them together, it becomes the sum of two cubes. On the other hand, if we carve out smaller dice from the bigger dice, we call them the difference of two cubes. Look at this picture of mortise and tenon joint used by carpenters to connect corners of wood furnitures like tables and chairs. Your task for today is to look for other examples such as these. You can find them anywhere in your locality or even inside your house. Make a list of them in your notebook. This will be submitted together with your summative test. Next is how to factor general trinomials. This one is tricky because we need to consider the signs of the middle and last terms.
Case 1. All terms are positive. Example. Factor x squared plus 5x plus 6. All terms are positive. First term, x squared. The factors of x squared are x and x. Last term, which is 6. The factors of 6 are 2 and 3, or we can have 1 and 6. Now, let's try looking for their sum. So the sum of 2 and 3 is 5, and the sum of 1 and 6 is 7. Since we are after the sum of 5, which is the coefficient of the middle term, we will choose 2 and 3. So the factors of x squared plus 5x plus 6 are the quantity of x plus 2 times the quantity of x plus 3. You can verify your answers by performing the FOIL method. Case 2. Only the middle term is negative. Example, factor y squared minus 8x plus 12. The terms of the factors are separated by minus sign. First term, y squared. The factors of y squared are y and y. Last term, which is 12, the factors are negative 3 and negative 4. Or we can have negative 2 and negative 6, or we can have negative 1 and negative 12. Since we're looking for the sum of negative 8, we're going to choose negative 2 and negative 6. So the factors of y squared minus 8x plus 12 are the quantity of y minus 2 times the quantity of y minus 6. Again, you can verify your answers by performing the FOIL method. Case 3. The last term is negative and the middle term is positive or negative. Example, factor n squared minus n minus 12. The terms of the factors are separated by either minus sign or positive sign. First term, which is n squared, factors are n and n. the last term, which is negative 12. The following are the possible factors of negative 12. So notice that only 3 or positive 3 and negative 4 will add up to negative 1. So the factors of n squared minus n minus 12 are the quantity of n plus 3 times the quantity of n minus 4. Again, you can verify your answers by performing the FOIL method. Which is true about the factors of x squared plus 2x plus 1? Which form of the factors is true for b squared minus 3b plus 2? Which factors of the last term are the right ones for c squared plus 6c minus 40? What are the factors of e squared minus 2e minus 3? What is the other factor of I squared plus 10i plus 9 if one factor is I plus 9? If m squared plus 4m minus 3, which is true about the signs of its factors in relation to the sign of the middle term? X plus 3 times the quantity of x minus 4 are the factors of the factors of the last term that fits y squared minus 7y plus 6 are. Which are the factors of v squared plus 14v plus 24? Which are the factors of w squared plus 2w minus 24? Today, we are going to apply what we learned so far from factoring polynomials. How do you solve problems you encounter in real life, and how do you deal with it? Okay, we will try to apply those methods. From this perspective, what we learn from mathematics will be totally useless unless we know how to apply it in real life situation. Let's begin with this problem. Example number 1, the product of two consecutive integers is 272. Find the value of each integer. Do you have an idea how to solve this kind of problem? Very good. Let's check if we have the same solution. First, let n is equal to the first integer. Next, let n plus 1 equals to the second integer. Since the problem is looking for the product of two consecutive integers, we have the first integer times the second integer is equal to 272, or we have n times n plus 1 is equal to 272. So if we're going to multiply n times n, the product will be n squared. And if we're going to multiply n times 1, the product will be n. So we have n squared plus n is equal to 272. Next, we're going to subtract 272 both sides. So we have n squared plus n minus 272 is equal to 272 minus 272. So we have now an equation, n squared plus n minus 272 is equal to 0. This is where what you learn from factoring general trinomials comes in. Based on what you learned, this is case 3, where the last term is negative. Can you still recall them? Very good. So we have now n plus 17 times the quantity of n minus 16 is equal to 0. Since we are looking for the sum of 1, we used 17 and negative 16 as factors. So we have now an equation of n plus 17 is equal to 0 or n minus 16 is equal to 0. So if we are looking for n, we have n is equal to negative 17 or n is equal to positive 16. So we have two answers. The first one is 16 and 17, or we have negative 16 and negative 17. We have two answers because both of them will give you positive 272. For the second example, let's consider the picture. A rectangular swimming pool is twice as long as it is wide. A small concrete walkway surrounds the pool. The walkway is a constant 2 feet wide and has an area of 196 square feet. Find the dimensions of the pool. Do you have an idea how to solve this problem? Let's see if we have the same perspective about this. Solution. Let W equals the width of the pool. Next, let 2W equals the length of the pool. So the area of the pool is A is equal to W times 2W. We have 2 feet of concrete walkway. Since the problem says the swimming pool is rectangular, we have the following equation. A is equal to W plus 4 times the quantity of 2W plus 4. We have the following equation. Total area is equal to the area of the walkway and the pool minus area of the pool. So we have 196 for the total area, including the walkway, is equal to the quantity of W plus 4 times the quantity of 2W plus 4 minus W times 2W. Next, let's find the product of W plus 4 times 2W plus 4. So we have 2W squared plus 4W plus 8W plus 16. And for the product of W times 2W, we have 2W squared. Next, we are going to combine like terms. So we have 2W squared minus 2W squared. We have, correct, it's 0. And how about 4W plus 8W? Very good. It's 12W. And copy positive 16. Next, we are going to subtract 16 both sides. So we have 196 minus 16 is equal to 12W plus 16 minus 16. So we have 180 is equal to 12W. So if we are going to divide 12 both sides, we have W is equal to 15. So the length is twice the width. So we have 2 times 15 is equal to 30 feet. So the length is 30 feet. So the dimensions of the pool are 15 feet by 30 feet. In your notebook, answer the following. First part, write only the equation that will solve the following problems. Number 1, find two consecutive integers whose product is 56. Number 2. Find two consecutive even whole numbers whose product is 168. Number 3. One number is 2 larger than other number. The sum of their squares is 100. Find the numbers. Second part, solve the problem. A rectangular plot is 6 meters longer than it is wide. The area of the plot is 16 square meters. Find the length and width of the plot. For your reference, here are the answers.
We are finished with our lesson for today. See you all next time for another fun-filled and exciting learning experience here in Tele Class. Mientras tanto, adios, Pasinon learners.